Question number 4 says Q is event that Nicola throws 2 fair dice and get a total of 5. So Q is a event which is total of 5 and we are throwing 2 dice. What does it say next? S is the event that Nicola throws 2 fair dice and get 1 low score 1 2 3 and 1 high score 4 5 6. So S is an event. Again we are throwing 2 dice and on first die, or let me say A and B, she gets 1 2 3 and on the other she gets 4 5 6 and vice versa. But on one score is low, on the other score is high. So these are the two possibilities. And one of the example that score would be 5 is she gets 1 on the first one and 4 on the second one. Now let's do this in detail. Question says, are the events Q and S independent? Are the events Q and S independent? For independent events, we have a condition that probability of A and B will be equal to probability of A multiplied by probability of B. Now let's just list these possible outcomes. So when we talk about Q, event Q, my possible outcomes are 1 and 4, total is 5. 2 and 3, total is 5. 3 and 2, total is 5. This 1 is on the first die, 4 is on second, then 2 on first, 3 on second, 3 on first, 2 on second, and 4 and 1. If I miss any one of these, question will be incorrect. So now what is the probability to get all these possible outcomes? Probability to get 1 on a die is 1 by 6, 4 on a die is 1 by 6, and this stays 1 by 6 for all, and I have 4 such events. So overall probability to get these is 1 by 9. Done with Q. Now let's do it for S. When we talk about event S, condition was first die may have 1, 2 and 3. So if it is 1 on first, we may have 4 on second. If I have 1 on first, I may have 5 on second, 1 on first, 6 on second. Possible outcomes. Then I have 2 on first, 2 with 4, 2 with 5, 2 with 6. Then I have 3 with 4, 3 with 5 and 3 with 6. Till now I have 9 outcomes. But the question says low on first and high on second, or high on first and low on second. So the other condition would be that if on A we have 4 5 6, on B we will have 1 2 3. So we are writing this again for this 4 now. So 4 on first, 1 on second, 4 on first, 2 on second, 4 on first, 3 on second. Done with 4. For 5, 5 1, 5 2, 5 3. Done. For 6th, 6 1, 6 2, 6 3. So probability that event S occurs for one of this 1 by 6 into 1 by 6. And how many are these in total? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So 1 divided by 6 into 1 divided by 6 into 18 is 1 by 2. Probability that event S will occur is 1 by 2. Probability that event Q will occur is 1 by 9. Probability of Q, probability of S. Now the question was that we have to show that they are independent events. So for independent events, we are using this condition that A and B, for our case, let me write probability of S and Q is equal to probability of S multiplied with probability of Q. If this is the case, yes, they are independent. So on the right hand side, probability of S is 1 by 2, and probability of Q is 1 by 9. On right hand side I'm getting 1 over 18. Let's talk about left hand side. So when we talk about Q and S, how many options do we have? I have to look closely. This is 1 4 and I have 1 4, right? I'm looking for other options. I have 4 1 and I have 4 1. No other option is same. So S and Q both, S and Q both, if this is the outcome, one may say this is event Q, but this is also event S. If 4 1 is the outcome, one may say this is event Q, but this is also event S. So I can say S and Q. So for S and Q having these outcomes, which is 1 4 and 4 1, 1 by 6 into 1 by 6 into 2 is equal to 1 by 18. So do we get left hand side equal to right hand side? Having said so, we can say events are independent.